So what types of solutions, what types of solutions have we talked about thus far? No solution and one solution. What does it look like to have one solution? When they cross, and then on a graph, it's when they cross. But then when we solve algebraically, what does it look like? When we get a coordinate. Okay, when we get a solution, we get a coordinate. Now, what does it look like on a graph if we get no solution? They will be parallel lines. They will never cross each other. What does it look like when we solve algebraically when there's no solution? The numbers don't work, right? The numbers don't line up. You get 0 equals 3, which doesn't happen. You get 100 equals negative 16. That doesn't happen. Okay? So today, we're going to look at the last set of flights for airplane problem number 2. So this is the half sheet that you picked up when you walked in. If you did not get one, you may go get one now. You need one? I'll get you one. Okay, so at the top of your paper, I have these pairs listed. Boys, I want you to graph flight C53 and flight T46. Girls, I want you to graph flights F24 and T46. Okay, this is written at the top of your paper. Also, you are only graphing. You are not solving algebraically yet. Okay. What do you notice about flight F24?
It's already answered.
F24. Is it in the format that we know how to graph? No. So you have to change or manipulate. Yeah, you're going to have to somehow change flight F24. What about flight T46? It's also weird. You have to change that one also. Okay? All right, so I'm going to give you, I needed to change flight F24 and flight T46. So how am I going to go about changing flight F24? What's keeping Y from being by itself? Yes, ma'am. The 2. Okay, what is this 2 doing to the Y? It is multiplying. How do I undo multiplication? Divide. So I'm going to divide just the 2y by 2, right? No, it's an equation. You have to do it to all of the terms. I tricked you. Okay, so y is equal to 8x minus 2, or divided by 2 is 4x plus 3. All right, so let's graph. Y equals 4x plus 3. Where do I start? Graph 3 on the y-intercept, or on the y-axis, because it's the y-intercept. And the 4 tells me to do what? Go up 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, so this is flight F24. Good job. Okay. Now, what about flight C53? What do you notice about flight C53? It's the same. Everything about that equation is the same. So I'm going to start at 3. I'm going to go up 4 over 1, up 4 over 1, and so on. Okay, I'm going to do a dotted line so that you can tell that it's still, the other line is still there. Okay? Can y'all see that? That there's 2 different lines there? Yeah. Not really? Okay, can you see yellow and red now? Okay, I'm going to change this to yellow. Yellow and red. Okay? All right, now, what do I need to change about flight T46? The 10y is what's causing it. So I'm going to divide, but I'm going to divide by 60 because that's what it's equal to, right? No? Why not?
There's no value. It's an initial value.
Because the 10 is what we're looking for. We need the 10 to be by itself. So, or we need the y to be by itself, and it's being affected by the 10. So I'm going to divide everything by 10. So that leaves me with y minus 4x equals 6. Now is the y by itself? Is the y by itself? No, the y is not by itself. Okay? What's keeping the y from being by itself? This negative 4x. I mean being by itself on the side of the equal sign. Okay, so I'm going to add 4x to move it over. So that y is equal to 4x plus 6, or 6 plus 4x. Either one. Okay, now I'm going to graph it. Where do I start? 6, and I go up 4 over 1, up 4 over 1. Well, if I can get it. Okay, so there was a quick change we needed to make. I originally plotted the second point from 0, 6 right here. Oops. I don't know how I did that. 6, 0, or 0, 6, excuse me, and I needed to move that next point right here. The line gets plotted basically the same though. So my question to you is this. What do you notice, what observations do you make about these three equations? Think about it, don't say anything. What observations can you make about these equations? They all have 4x plus a number. Okay, what do we call that 4 that they all have in common? They all have the same rate of change. Very good. Okay, they all have They all have the same rate of change, 4. Okay, and then he said, and it's also plus a number. Okay, what else can you observe? Jordan, what else do you observe? The first two have not only the same rate of change, but also the initial value. So what does that tell you about the first two lines? They are the same. Okay, what two lines are they on our graph? The red line and the yellow line. Okay, so if the two lines are exactly the same, you can't see that. If the two lines are exactly the same, which happen to be the red and the yellow lines, how many points do those two lines have in common? How many points do those two lines have in common? Infinity? Why do you say infinity? Because they'll always have the same thing. What makes you think that they're always going to have the same thing? Because they're the exact same equation. Is there ever going to be a point where these lines are not the same? Can that be true? No. So this arrow right here tells you that that line does what? Keeps going. So how many more points are they going to have in common? A lot. Are we going to be able to count them? No, because is the line ever going to stop? No. So how many points do they have in common? All of them. Infinite. Okay, so I want you to write with me that infinite solutions, or same lines have infinite solutions. Same lines have infinite solutions, and that is flight C53, C53, and F24. Okay? What do you notice about flight F24 and flight T46? They have the same rate of change but different initial values. What two equations are they on the graph? What two lines? Which two lines? What colors? The blue and the red. The blue and the red, right? How many times do these two lines cross? Never? They will? Potential they could cross? If we went all the way up, would they ever cross? Let's check. Let's check. When we solve algebraically, we find out that these two equations in the orange are actually the blue line and the yellow line. And when we solve algebraically, we end up with 0 is not equal to 3. And if 0 is not equal to 3, then how many solutions are there? None. No solutions. Okay, what kind of lines are those then, if they never cross? Parallel lines. So what conclusion can we come to?
They're never going to cross.
That parallel lines have no solutions. Okay, so I want you to write that also. I'm running out of space here. Parallel lines have no solutions. Parallel lines have no solutions.